Exercise 1.1, question number 12. Find the matrix A for which A into product of a matrix is equal to another matrix. Given here, A into the matrix 5, 3 minus 1 minus 2 is equal to another matrix which is 14, 7, 7, 7. If now the given equation is of the form sum AB is equal to C. Our aim is to find the value of the matrix A. So I post multiply on both the sides with B inverse. So post multiplying by B inverse on both sides, we get A, B inverse is equal to C into B inverse. B inverse we know is equal to the identity I. Therefore, we get A is equal to C into B inverse. We know what is B inverse. We know what is B matrix. B we have taken to be is equal to the product matrix with A, that is 5, 3 minus 1 minus 2. For this, first we find determinant of B which is equal to minus 10 plus 3 which is equal to minus 7 not equal to 0. Edge of B will be is equal to interchanging the diagonal elements. Minus 2, 5, change the sign of the non-diagonal elements. So that will be 1 here, and then B inverse will be is equal to 1 by determinant of B into edge of B, that is minus 2 minus 3 1 5, multiply by the minus sign inside the matrix. So we get 1 by 7 times of 2 3 minus 1 minus 5. We have found what is B inverse. So now we are going to find what is the A matrix. A is equal to the C matrix which we have taken, which is on the right side. So A is equal to product of C. C is equal to 14, 7, 7, 7 into the B inverse matrix, which is 1 by 7 times of the matrix 2, 3, minus 1, minus 5. We know matrix multiplication here, and therefore we multiply both the matrices. Multiply, we see in the first matrix, we see here the first matrix, all the elements are multiples of 7, and therefore we multiply 1 by 7 inside the bracket, and we get this is equal to 2, 1, 1, 1 into the matrix 2, 3 minus 1 minus 5. Now this is equal to first row first column elements, we multiply 2 into 2, 4 plus 1 into minus 1. So we get here 4 minus 1. First row second column will multiply, we get 6 minus 5. Second row first column 2 minus 1. Second row second column 3 minus 5. Now this is equal to 3, 1, 1 minus 2. This is the value of the A matrix. Next, moving on to question number 13. Given A matrix, B matrix, C matrix, and we are asked to find here the value of the X matrix, given that the product of A, X and B is equal to C. Our aim here is to find the X matrix. So to find the X matrix, first we post multiply by B inverse on both the sides. So we post multiply by B inverse. We get B inverse is equal to C into B inverse. We know B inverse is equal to I, and therefore AX is equal to C B inverse. We want to find what is X here. So next I pre-multiply with A inverse on both the sides. So we get A inverse AX is equal to A inverse C B inverse. Now A inverse is equal to I, identity matrix. Therefore here X matrix is the product of A inverse matrix, C matrix and the B inverse matrix. Now we are going to find what is A inverse and B inverse. A matrix we know is equal to, from the question, 1 minus 1 2 0. Now determinant of A will be is equal to 1 into 0 0 plus 2, which is equal to minus of minus 2 plus 2 not equal to 0, and edge of A will be is equal to 0, 1, minus 2, 1. Now A inverse will be is equal to 1 by 2 times of 0, 1, minus 2, 1. Now we are going to find what is B inverse. B matrix is equal to, from the question, 3 minus 2, 1, 1. So determinant of B will be is equal to determinant of 3 minus 2, 1, 1, which is nothing but 3 plus 2 is equal to 5 and not equal to 0. We are going to find what is edge of B. Edge of B is equal to 1, 2, minus 1, 3. Now finding the B inverse. B inverse is equal to 1 by 5 times of 1, 2, minus 1 and 3. We have found now what is A inverse, what is B inverse. We are going to find the X matrix here. So X will is A inverse, what is B inverse. Now X is equal to, we have found what is A inverse, what is B inverse. Now X is equal to A inverse C into B inverse, which is equal to A inverse is equal to 1 by 2, 0, 1, minus 2 and 1, which we have found already, into the C matrix from the question, which is equal to 1, 1, 2, 2, and B inverse matrix, which again we have found, which is equal to 1 by 5 times of the matrix 1, 2, minus 1 and 3. Now take the product of all these three matrices, which is equal to 1 by 2 into 1 by 5. 1 by 2 into 1 by 5 gives us 1 by 10. Multiply the first two matrices. So we get 0, first row, first column, 0 plus 2 will be is equal to 2. Next, first row, second column, 0 plus 2, 2. Next element, minus 2 plus 2, 0. Next element, second row, second column, minus 2 plus 2, 0 into matrix 1, 2, minus 1 and 3, which is equal to 1 by 10 times of, again multiply these two matrices, first row, first column, gives us 2, minus 2, 0. First row, second column, 2, 4, 2 into 2, 4, plus 3 into 2, 6 gives us 10. Second row, second column, 0. Second row, first column, 0. Second row, second column also 0. Now multiply with 1 by 10 inside the matrix, we get is equal to 0, 1, 0, 0. This is the X matrix which we are asked to find. That A inverse is equal to 1 by 2 times of A square minus 3i. We are asked to show in this question A inverse is equal to 1 by 2 times of A square minus 3i. I am going to simplify this equation. It can be written as 2A inverse is equal to A square minus 3i. Now multiply with A throughout. We get 2A inverse into A is equal to A cube minus 3 times of A. A inverse we know is equal to I. The given equation can be written as A cube minus 3A. Take this 2i to the right, becomes minus 2i is equal to 0. So it is enough for us if you show that this value, instead of showing this A inverse is equal to 1 by 2 into A square minus 3i, it is enough if we prove that A cube minus 3A minus 2i is equal to 0. So first we find what is A square. Given from the given question, A is equal to the matrix 0, 1, 1, 1, 0, 1, 1, 1, 0. We are going to find what is A square. A square is equal to A into A, 0, 1, 1, 1, 0, 1, 1, 1, 0 into the, again repeat the same matrix 1, 1, 1. We know matrix multiplication, first row, first column, 0 plus 1 plus 1, so gives us is equal to 2. 0, first row, first column, 0 plus 1 plus 1. First row, second column, 0 plus 0 plus 1. First row, third column, 0 plus 1 plus 1. First row, third column will be 0. This element is 0. So we get here 0 plus 1 plus 0. Second row, first column will be 0 plus 0 plus 1. Second row, second column, 1 plus 0 plus 1. Second row, third column, 1 plus 0 plus 0. Third row, first column will be 0 plus 1 plus 0. Third row, second column will be 1 plus 0 plus 0. Third row, third column, 1 plus 1 plus 0. So gives us the matrix. This is equal to 2, 1, 1. Second row will be 1, 2, 1. Third row will be 1, 1, 2. This is the value for a squared. We want to prove a cube. Find now. A cube will be is equal to a square matrix 2 1 1 1 2 1 1 1 2 into a matrix, which is equal to a matrix we know that is 0 1 1 1 0 1 1 1 0. Multiplying both the matrices, we get first row first column will be is equal to 2 into 0 0 plus 1 plus 1. First row second column will be 2 plus 0 plus 1. First row third column will be 2 plus 1 plus 0. Second row first column 0 plus 2 plus 1. Second row second column 1 plus 0 plus 1. Second row third column 1 plus 2 plus 0. Third row first column 0 plus 1 plus 2. Third row second column will be 1 plus 0 plus 2. Third row third column 1 plus 1 plus 0. Now this is equal to the matrix 2 3 3 3 2 3 3 3 2. Next we are going to find the value of a cube minus 3a minus 2i. So we are going to find the value of a cube minus 3a minus 2i, which is equal to a cube value is known to us 2 3 3 3 2 3 3 3 2 minus 3 times of the A matrix. So A matrix is 0 1 1 1 0 1 1 1 0 minus 2i. So 2 times of the identity matrix 1 0 0 0 1 0 0 0 1. Now this gives us 2 3 3 3 2 3 3 3 2 minus multiply 3, so 0 3 3 3 0 3 3 3 0 minus 2 0 0 0 2 0 0 0 2. Now this is equal to first element 2 minus 0 minus 2 gives us 0. Next 3 minus 3 minus 0 gives us 0. 3 minus 3 minus 0 gives us 0. Similarly 3 minus 3 minus 0 gives us 0. 2 minus 0 minus 2 gives us 0. 3 minus 3 minus 0 gives us 0. Last row similarly gives us 0. Hence we have proved that is a cube minus 3a minus 2y is equal to 0, or that is the given question is a inverse is equal to 1 by 2 times of a square minus 3i. Next question number 15. Next question number 15. Decrypt the received encoded message given in the form of a matrix with the encrypted matrix. Encryption matrix is given, and that is decryption matrix as its inverse, where the system of codes are described by numbers from 1 to 26 to the letters A to Z respectively, and the number 0 to a blank space. In this question, we take the matrix, the encryption matrix, to be the encoding matrix taken to be is equal to A, and the decryption matrix according to the question is the inverse. For the given A matrix, we are going to find what is A inverse. The A matrix is taken as the encoded matrix. Encoded matrix A is equal to -1, -1, 2 and 1. For this we find what is determinant of A, which is equal to determinant of the given matrix, which is -1 plus 2, which is equal to 1, not equal to 0. We find what is adjoint of A. So adjoint of A will be is equal to 1 1 minus 2 minus 1. A inverse we find, so A inverse will be is equal to 1 by 1 into 1 1 minus 2 minus 1. This is A inverse, which is equal to 1 1 minus 2 minus 1. This matrix is called as the decoding matrix. inverse matrix is the decoding matrix. Now we are asked to find what is the code here. The letters from 1 to 26 take the numbers from A to Z. A is equal to 1, B is equal to 2, C is equal to 3, goes on up to Z is equal to 26. So we form a table here. What is given in the question. The decoded matrix will be taken as A inverse, and the decoded matrix from which we are going to find the code will be taken as B into A inverse. So the first code, B code, what is given here? B matrix given here is 2 minus 3. Next 24. So the first row will be 2 minus 3, 24. Next, the A inverse matrix, what we have found, will be 1, 1, minus 2, minus 1. Similarly here, 1, 1, minus 2, minus 1. Now we take the product of 2, minus 3 and 1, 1, minus 2, minus 1. So first row and the first column will give us 2 minus 2 into 1 is 2 plus 6 will be is equal to 8. Row and the second column 2 plus 3 will be is equal to 5. Similarly, take the product of 24 and the matrix inverse matrix 1, 1, minus 2, minus 1, which gives us is equal to 20 into 1 gives us 20 minus 8 is 16. Next row and the second column gives us 20 minus 4. The first row and the first column gives us 20 minus 8 gives us 12. The row and the second column gives us 20 minus 4 gives us 16. Now in the sequence of the decoded matrix, the sequence of decoded matrix can be written as 8, 5, and the next matrix is 12, 16. So the message so received will be is equal to 8 denotes the letter, alphabetic letter H, 5 denotes the letter E, 12 denotes the letter L, and 16 denotes the letter P, and the message so received will be is equal to HELP.